So learning objective 7 is to differentiate between the three main states of matter. So our three main states of matter are solid, liquid, and gas. So you can draw a particulate diagram of a solid. So each little circle is an atom or a molecule. The thing about a solid is it cannot compress. So if I put a solid onto a machine press or whatever, if that solid's brittle, it's going to break. It's going to bust apart. If the solid is a little bit more malleable, that type of thing, then it's going to be able to be flattened and it'll flatten out. So a solid has definite volume and shape. So definite volume and shape, which means that it has a certain shape that it holds, and it has a definite volume, which means I can measure that volume. So for a solid, like if I've got a cubic solid, it's going to be in a cube. So then you have a liquid. So if this solid melts, then I have this kind of liquid thing. So a liquid, and notice how it goes all the way to the bottom. That means it doesn't really have a shape that it holds. It takes the shape of the container. So again, liquids still, we don't have a lot of room, so these guys cannot compress volume. But again, not shape. So it does not have definite shape. It just has definite volume. So that's a liquid. And notice how like these atoms are very, very close together. And then these atoms are a little bit spaced further apart. So then if I move through the next thing, right, I become a gas. But a gas can compress. The main reason that this gas can compress is because it's got so much space between the actual atoms and that type of thing. So you don't have as much space between a liquid, between atoms in a liquid, and between atoms in solid. You definitely don't have that much space. This does not have definite shape. It does not have definite volume. So it's got an indefinite shape and volume. So my volume can change depending on certain properties of the gas and that type of thing. So spacing for my solid is very close together. My movement is a slight vibration in place. For my liquid, my spacing is still close together. I still have a liquid is still pretty close together. My movement for a liquid, they slide past one another. So again, like these are very, very close together. These are close together, but they're kind of separated. There's a lot of movement within a liquid, not as much movement in a solid. So my spacing for a gas is very far apart. Unless I like push them together, if I compress them down, then they would come closer together. My movement for a gas is very fast in straight lines. Now we can kind of talk about energy here. So we can talk about like what is the energy of these, and we can talk about kinetic energy, right? So going this way, I am increasing my energy. So one thing that we can kind of talk about here is matter is very interesting. So this is not a complete list of the states. So solid, liquid, and gas are the three main states of matter. But you also have plasma. You also have what's known as a Bose-Einstein condensate, if you want to look that up. You also have a white dwarf star that is a different state of matter. So like you've got all these different states of matter. So this is not a complete list of the states of matter. So what we find is that matter is very interesting at close to absolute zero, as well as very high temperatures. Very high temperatures, it's kind of interesting. So at very high temperatures, what we get is a plasma. And that is how to differentiate between the three states of matter at the atomic level. So we're going to talk about spacing, movement, the ability to compress, whether or not they have definite shape or definite volume, or if they don't have definite shape and don't have definite volume, and talking about energy. So gas being the highest energy, having the highest energy, and solid being the smallest amount of energy.